Just yeah.
Yeah.
This one anyway. So I'll post what we do. All right. How was the homework?
It's hard.
Yeah. You forgot to do it.
Yes.
Oh, shoot. Okay. Should I allow you to still do it? If you miss to do that? No, I'll let you do it.
Okay. I'll get that one.
What I'm gonna do, I'm gonna go over a few things that I didn't get a chance to go over. Um, it's not that I didn't go over it, it's just with frequency distribution, I went over the meat of what was necessary. But there are some things that we do need to discuss, like skewness. I might have a question about skewness on it, maybe not. So I'll talk about skewness. I'll talk about the different types of graphs, and then we'll move on to chapter 3. Okay. All right. Let me get here. Start this. How was y'all's weekend? It was a long weekend. That's what you want, right? Yeah. All was perfect. Went to a football game. I went to go see Andy play. Vanderbilt. Got blasted. Then Saturday, no, yeah, Sunday, went to a cookout, just food. And then Monday, just grilled out roasted salmon, some shrimp kebabs. Good. Still got some. It's always good. You know, leftovers are always good. All right. So which y'all go home? You know, I go home. Where you at? Yeah, Chicago. You go home? You get some barbecue?
Yeah.
Okay. Barbecue's always good. You get some?
I'm local and it just gives us.
Oh, no. Don't nobody cook. I need to labor there. Oh, hmm. Hey, we're gonna we gotta make sure y'all get y'all have some family time and the people y'all care about. All right, let's do this. So this stuff is not really, you're really not gonna need to graph. I'm not gonna ask you. The first exam I'll ask you to graph. But from this point moving forward, I usually will not ask you to graph anything. You'll have to compute a lot of things, but you won't be asked to graph. So I'm going to briefly go over. I know I need to go over skewness because that's going to be something that we're going to talk about a lot as we move into a normal distribution, z-scores, t-tests. Okay, so you need to have an idea of what that means. Okay, so we talked about the frequency distribution table. Okay, the frequency distribution chart, and now we're going to just talk about how we construct and how the data is organized. You get one. Okay. So again, the way we structure and uh, the way we withdraw or compute a diagram graph, you have to have a y-axis. Okay. You have the Cisco, excuse me, Cisco, okay, and the order. Okay. So you have the x-axis, y-axis. I'm not sure why they named them that, but again, those are the signs. You just use x-axis and y-axis. Usually, the categories that you have on the measurement scale are going to be on the x-axis. Everything that we're going to be measuring, counting, is going to be on the x-axis. And the way that we're putting the frequency is going to be on the y-axis. Okay. And so if you look at any graph, you'll have, right? So on the x-axis, um, males would be uh, in those things that we're measuring go the x-axis, and the frequency counts on y-axis. Okay, so it's going to be really important that we know the structure. It's really important that we know the structure because on the exam I might ask you to draw a graph with the data that should present. Okay, both axes should start at 0, right? So this should be 0 count. And that should be 0 count. This is for discrete variables. But if I was doing a continuous variable, then I would just 1, 2, 3, 4, 5. Again, then I have to start at 0 and go at any interval. Right? We talk about those intervals. You want pretty easy. Okay. So the x-axis and the y-axis, these are the rules of thumb. Don't necessarily have to do this. But again, said the height of the y-axis should be about 3/4 the length of the x-axis. So you see that this y-axis is shorter than the length of the x-axis. Okay? So that's usually how it is constructed. Usually how it's constructed. 2/3 to 3/4 of the x-axis. These are just little principles. You may see different, see them constructed depending on the author. Okay? So you can do graphs on pretty much any scale of measurements. So we talked about nominal, we talked about ordinal, we talked about continuous variables, we talked about ratio and integral variables, scales of measurement. Again, you can just about anything. Right? Any of them you can draw a graph. So I showed you one that had the three variables, nominal, right? Male and female. But again, this is just numerical, so you can draw a graph. When you are doing a graph for integral or ratio data, what is ratio data? Give me an example of something for a variable that would be ratio. Show up. The amount of ice cream would be, because ratio means there is an absolute zero, right? So you can't have negative ice cream consumption. You might be able to have negative temperature. So that would be integral. Okay, so integral would be Fahrenheit temperature. But the amount of ice cream eaten would be a ratio scale. The number of people in this classroom would be ratio, because again, I can't have negative students, right? So again, when you're using numerical scores, again, you want to represent all the scores on the x-axis, minimum through the maximum value. So whatever minimum is, whatever the maximum, you don't want to cut it off, right? So if I had 10 people in one category, right? If they scored 10 on the test, I don't want to just cut it off except because I'm missing that, right? You want to include every man, every max. Make sure that you have everyone represented. Everyone represented. Okay. But again, you're including all scores, even those that have okay. Again, these are just general principles, general rules. All right. So here's just an example. Okay, this is what we call a histogram. Okay, we call this a histogram, and the distinguishing factor is many people say, "Oh, this is a bar graph." The reason this is not a bar graph is because the lines where the bars touching each other, and usually you can't represent anything that is nominal with histogram. It's always going to be mostly going to be numerical. Okay, with a bar graph, it could be nominal. Okay, but with a histogram, names, but with histogram, continuous or discrete. Okay? So for this particular one, these are my x items, my score, and then these are my frequency counts. Right? So of course we see highest peak there at the 4, okay, and 3, 2.5, 2.2, okay, so on and so forth. You might execute that construct a histogram with the data. Very, very simple. Very, very easy. Those are software. It's tough to treat. Yeah. All right. When you are doing group data like we talked about before, when we have too much data, then it's important that we group it so that we make the graph readable, right? So when you have too many scores that are a huge range of scores, it's oftentimes best to group it so that you can put it in a graph, show the groupings on the graph on the x-axis. Okay, I'll show you an example in a minute. Okay, but again, just like we talked about those intervals, right? We're looking at grades for an example, right? We got 10 units, So we'll say we started at 50, 59, then 60 to 69, so on and so forth. Those 10 units. Okay. And then we also, again, just put in the frequency count for those group variables. Okay. Again, you are losing information because I can't ask you, how many people got a 95 because again, all of the information. But I do know who got a 90, 99. Okay. All right. Here's an example of the histogram group data. So they just took all the data and they grouped it. Okay. One thing I want to say is spacing. So this is a frequency distribution and the children's house. Yes. So everybody, so they just put this expression on that. Okay. Okay. Grouping data just like we did for the frequency distribution. This is our table. And this is our graph. All right. Questions about histograms? Yeah, histograms, bar graphs, two different things, two different graphs. Um, so you have formal histograms and you have informal histograms. The only difference between a formal histogram, so this would be a formal histogram, okay? Then an informal histogram, the all I'm doing is instead of doing plots, for the informal, you may see plots. Either, but usually if you're going to see some research in an article, they're going to go with the formal. Okay? No blocks. Matter of fact, I will give everybody an additional attempt for the whole second time. Okay? So you can have another. All right? Cool with everybody? Everybody cool? Got it? Yeah, yes. She got leaving now. All right. Another type of graph. This is for integral or ratio data. Okay. Is a what we call a polygon. Okay. Constructing a polygon. And I'll show you the graph next. All right. The way you construct a polygon, you're going to include everything from 0 to the maximum. Okay. And you're going to form a polygon shape out of the graph. Okay. So I'll show you what that looks like. But at each frequency point, say I had 10 people with one, I had 20 people with four, I had 6 people with 25, or 5, just 25 people with 6, 5 people with 8, then I had 5 people with 10. Okay. So for a graph like this, these indicate the frequency heights. Okay. And then all I would do with polygon is connect the dots. I go from 0 up, back down, and then it will close out. Okay. So that's just polygon. Different type of graph. Okay. Yes, ma'am.
Like, on the period of time, and,
Okay. All right. Let's see. Let's go back here. So for interval and ratio data, you're going to use either a histogram or a polygon graph. All right, those are two of the graphs that we'll use. When we start talking about ordinal and nominal data, then you would use bar graphs, and we'll talk about that. Okay, so those are things that you have categories, right? It's nominal categories, ordinal categories. But for interval or ratio data, you're going to be using histogram. You'll be using histogram. And that could be for continuous variables or discrete variables. So in this particular case, those are continuous variables, quiz schools, right? And so then you have to use that's the distribution for histogram. Okay. And again, you can do an individual distribution, versus distribution without the data, or you can do that. Okay. But for ratio, interval data, you can use histogram. And that is continuous and discrete data, numerical data. Okay. If I'll show you. So polygon, okay. Again, it's both polygon is also interval and ratio. Okay. That's why I'll give you a chance to. All right. Here is one from data. So T, T, go ahead.
how, like, go down.
You're connecting two cases. Just like that. It's a good question. They always connect back to that. All right. Because if it didn't, it would be fine. Yeah. Because if one slows in, it would just be a line graph.
You don't just start out.
Yeah. So that is an actual shift. So if I just did this, what is it? Line graph. Yeah. Good question. All right. So when you have nominal or ordinate data, you're going to use bar graphs. Okay. We've used bar graphs before. I know you all maybe used the pie chart before. Those are other graphs and charts that you can use to represent nominal or ordinal data. And again, nominal data is names or categories. Okay. So if I had the number of freshmen, sophomores, juniors, and seniors at Alabama A&M University, that would be nominal data. Okay. Those are names and categories. If I had male and female, that would be nominal data. Okay. And so you use a bar graph to do that. It is very, very similar. I told you before. However, second order, the way you put them, they could be in alphabetical order. You put it in order that you want the name of the categories to represent. Before in the order of first place, second place, third place. Okay. That would be how you might do it. So, no width or depth, or measurable width or interval. Okay. So here's an example. This is a bar graph. Right? So the bar graph looks very, very similar to a so for this example, 20 inputs separate. So you might get asked a question to be able to interpret and get identified with that. So I might ask you how many people had. So just knowing how to read it back for sure. Okay. This is interesting because we talk about how we construct graphs, and the way we construct graphs is by using the proper scale. Okay? So when we talk about this, somebody's running for mayor, okay? And the opponent is like over the last 3 years, almost out has gone under your use. Which one is the use if you're going to use out? You're going to use it right? Because it shows in home side. But in actuality, if you use a pretty decent scale, right? 15, 20, 25, 30. Those two steps, so maybe I would do this is like two, you can see more accurate picture by using a different scale. This is not good either because the scales are 200 to 400 to 600, right? So now it doesn't look like the mayor would actually use this graph because it doesn't look like there's much of an increase out, right? But again, when you look at the numbers, you got 218, 225, 229, right? So I might use the scale of 2, right? Just to represent the graph. But people misuse graph all the time. The point across or to confuse me. Okay. All right. So now we're going to begin to talk about what we call distributions. Okay. So when a population is extremely small, then the scores for each member, like I said, you can construct a frequency distribution graph, just like Instagram and or Bark. Right? But if the population is extremely large, it's not possible to do. Okay? So the graphs will be based on the relative frequencies, the relative frequencies, percentages, right? So now we're going to use percentages instead of the scores. Because again, we want to incorporate the percent. So instead of using individual scores, now we're going to use those frequencies. Relative frequencies will give us similar data. If you ever see it, very similar. Okay. I'm going to show you examples of this. Okay. One thing that we're going to be using for probably the rest of the semester is the definition of what we call a normal distribution. And a normal distribution, I'll show you those drawings out. So a normal distribution looks like this. Okay. That's a normal distribution. You have body a lot in the body here, and you have fewer in the tails. Okay. One variable that has and is a normally distributed variable, height, weight, um, shoe size, all of those are normally distributed variables. So you got a lot of people in the average here in the middle, and then you got a lot of people who are short, or fewer people who are shorter, and then you have a few people who are extremely tall, right? So the average height might be 5'6", and then everyone out here is taller than 5'6". Everyone to the left is shorter than 5'6". And then the tails, those are the most extreme. So these are people who are under 4 feet, 3 feet, so on and so forth. Okay. So it is a common IQ scores is the same way. IQ scores almost any variable. Perfect. Okay. We'll learn a lot about it. So here are just relative frequency. Okay, so instead of using all of the and you use relative frequency. So only for the 6% it's then 5% say it's a anybody pick it? Yeah, we can do all this. Okay. Home girl. Okay. Hey, so like man, it's a home girl family. Yeah, that's a family. That's good. My dog is a road free. I've been trying to keep it. It's not. I won't show you him, but if I show you one of them, you see them. See a picture. A giant schnauzer. He's like, I think right now he's probably at 100 pounds. Maybe no, he's like 90. It's summertime, so they don't eat as much. Uh, yeah. Really random. It's just like if you seen one, especially he's all black, just like that. Yeah, that's my dog. I got him when I was in grad school, and then towards the last 2 years. So he's been with like when I was like writing my dissertation, he just curled up on my feet. But yeah, came down and got him. 13 hours. We drove back. So every time I came back, it was on the road dog. We used to ride. Yeah, we used to ride. So yeah, he's special. My fiance is Fredo. Not yet. Oh no, no, not yet. She don't like big dogs. Yeah, they are. They can. So, oh yeah, yeah. Oh yeah. Yeah, I don't like that bark. Yeah, yeah. The like Jackson doesn't really bark. Like, he'll bark when people come to the house. Like he hears me, but he don't really bark. He's really he has fun. He loves people. Loves people. All right. This is what a normal distribution would look like. Like I told you before, many of the variables that we engage with on a daily basis are numbers. So these are SAT scores. Have a lot of people who are average. You have some people who are get that far. Or IQ scores, same thing. A lot of people in the middle here. You got Einstein, with Jason Hawking, and all those other people here. You got people who are a little less. Right? Well, again, most of talk about population distribution are going to look similar. So the more people you get in the population, the more it's going to look like in numbers. All right. So now we're looking at shapes. Shapes of distribution, and with a normally distributed, it's symmetrical. So if I chop this in the middle, this one is not drawn extremely symmetrical, but if I chop it in the middle, I can flip it, it'd be the same. Okay. That's how a normal distribution is. Okay. However, there are instances where there's information that's piled up on the left-hand side, it will be considered a positive skew. Okay, so it'll look like something like this. Something that is positively skewed. The way that I was taught is the tail points to the sun. Okay, so if the tail is pointing to the right, that means it's positive because the numbers are going to the right. Okay, if this would be a positive, and this would be a negative. Okay? Because not the tail is pointing to the negative. And the tail points to the sun. So when they ask you, is this positively skewed or negatively skewed? There are other ways to determine it as well. Okay? Because when we start talking about measurement of central tendency, you can look at the mean, the median, and the mode, and you would be able to tell if it's just based on the values, if it's positively skewed. You don't even have to look at the graph, and you'd be able to determine, okay, it's kind of negatively skewed, right? Because this would be the mode. All that big super mode. Yeah, it's where most of the points are. Okay, and then you would have the median right here. This would be the mode. This would be the median. And this would be the this would be. You don't even know this right now, but I want you to. Oh, but you will need to. What is the median? Good, good. And so, in information like this, when we talk about measures of central tendency in the next chapter, it's going to be important when we're trying to represent a distribution that we choose the right central tendency measure, right? I would not. Why do they use median household income and not mean income? They use median household income. So one thing that 20% population that has, I think it's making, they have at least 70% of the world's income, something like that, something crazy, right? So if I took the average, then those incomes are going to pool the income all the way towards the billionaires. So they use the median because that is the middle of the distribution, right? If we took into account all of those outliers out here, then it's going to pool just like with a mean, it pools everything. everything towards the highest score or to the lowest score. Okay. All right. So these are examples. Okay? These are symmetrical. This is bimodal. Positive. Okay. What's the body in there? What is that? Cheating. Look at this body before. It is positively skewed. Okay. Because again, it's pointing to the right. Tail points you, takes you there. Okay. What about this one? It says the population of the population of the states of the United States would have what kind of skew distribution? Population of each state. You say it's symmetrical. We're looking at the population of each state. That's true. So it doesn't have a distribution above. So you said, but you're making a point right now, right? You said there are some states. That's what I'm saying. So okay. So say this is instance. So say you, yeah, yeah. So I'll show you. Yeah. A lot. You were to have it. Okay. So it would look like this. I just cut this in half. But the cap point here, and then you have yeah. So I just put all the numbers in and boom. So that's positive. And depending on how you make it negative, or you're put yeah, that's fine. That's fine. It could have been out of one, but in this case, all right. True, false. It says it would be correct to use a histogram to graph parental marital status, data, single, married, divorced from a treatment center. Good, good. That one's false. Second one, it said it would be correct to use a histogram to graph time children spent playing with other children, data collected in children's treatment. All of these. So these times become kind of measurement would that be? Would it be nominal, ordinal, ratio, or time spent? What is time? Is time a interval or ratio level? We have negative time. It's ratio. It's ratio. It could be that. It has no, and you can't do a ratio with. So I can't say since today was 85 degrees and yesterday was 45. I can't say it was twice as hot. I don't know if it's twice as hot. What does that mean? Right? So the ratio has an absolute zero to it. All right. So If it's zero, there's an absence of it. If there are 0 people in this class, there will be no people in this class. Yeah, that's what being, I guess, an absolute zero. So time is an absolute zero. Can't have negative time. Age, 10 consecutive. I mean, that's the question. That'll be on the exam. Guaranteed. When did I say the exam? Yeah. It's not this week. It's next week. It's next 13. Yeah. Yeah. So next week. Next Wednesday. Next Wednesday. I give you one. Like I said, the study guide will be the terminology that we use, and it will be, we'll probably get through chapter 3. So that would be 1, 2, chapter. Okay. And the homework questions give you an idea of what some of them will be. If you study the study guide, it'll be pretty good. Okay. Last thing we'll talk about is the stem leaf display. Very, very easy. Very, very easy. I don't know if we have to spend a lot of time. Okay. If you have to do a stem leaf display or interpret information from a stem leaf display. So if I have a double digit number, usually I start from the top, highest to lowest. So this would be for double digit numbers, right? So we got stem, and then my leaf. So I can do 6, 4, 5, 2, 1. Right. So I'm looking at this stem and leaf display. If they're asking me for the total frequency, all I have to do is count the numbers over here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's the frequency. Or frequency, total frequency, total number of scores. Okay. And then if they ask me how many people were had scored 70, it would be 1, 2, 3, 4. One person scored 79, one person scored 78, one person scored 75, 74. Okay. So again, it's just using this is the stem, and then the leaf is the second. Okay. Or it could be, say I had 102. So then my stem would be 10, 2. Okay. Stem and leaf. All right. So here's a question. Oh, you need to go back. Anyway, medium mode is get into meat. 3. So this is fun. It's good. It's real good. I think we'll have fun this way. Y'all seem like y'all are motivated.
Excuse me.
Yeah, I was like, oh, yes, ma'am.
Is that your example, or you got that from the from your notes? Is that your example on the board? I can't see behind you.
Oh, my bad. There you go. That's my example.
All right, thank you.
Kimmy, can you hear me?
Yeah, I can hear you. You be breaking up, but I mean, it's enough to where I can still hear you though.
Okay. Uh, yeah. Yeah. Well, then, see, uh, okay. So that's what the score is shown in the stem and the display. What is the lowest in the distribution? The lowest distribution. Everybody got lowest score. I've heard the right answer twice. If you want. Everybody see that? So this is 90s, 80s, 70s, 60s, and 50s. Okay. So we talk about the lowest score in the distribution. We're going to be looking at the bottom and then see which score is lowest. 51, 54, lowest out of those two. 50. Okay. All right. And another one. So for the score shown in the following stem and leaf display, how many people have scores in the 70s? 4. B. Easy enough. Good. We're almost done. Any frequency distribution is suitable for a stem and leaf display. Why is it? Yeah. Okay, good. And what else? What else could you do? That would probably wouldn't fit. Yeah, that's the frequency. Okay. Yeah. So then you can have 21, 21. Yep. I did another one. What else? So I know the nominal that did go. What else? What other reason? What other frequency distribution? Groups. Could use groups. Because again, how would I identify the leader? They're groups. Okay? It's good. Good, good, good. All right. Second one says a score of 54 is displayed as 5 stem and 4 as a leaf in a stem leaf. Yes, it's true. It's correct. Okay. False. Anything that's groups, and you can't do the stem leaf. Okay. Don't mess it. So I'm gonna go for a few minutes in chapter 3. Okay, just introduce it, and then we'll get out of here. Okay. Sound good? How y'all feeling? How much sleep y'all getting in? I know you're mom. Yeah, that's what we do. Uh, I hope. Yeah, yeah, yeah. 3 hours, that's not good.
I find it really hard to like go to bed.
Yeah, yeah, yeah. Mhm. Mhm.
It's
Yeah, yeah. But
yeah.
really? Yeah, yeah,
It's exactly the fear that I don't
yeah. I feel it. Sleep is important.
Monday, Fridays,
Yeah,
where I was out 3 hours.
3 hours. Wow. If you can get it.
If I would sit up. That thing, trying to go.
If you gonna lay down, you might as well get up and do some work.
Here's the thing, I'm starting to find that we can get 3 hours, or we can get absolutely nothing. So I have to lay there. Like,
Yeah. You don't take melatonin?
I was pregnant and it's like that. And I take notes.
Yeah.
It's
Yeah. So you don't sleep at all? Yeah. Mm. Okay. Yeah. Yeah. My son. I've done that too. Yeah, I was a sleepwalker. My mom caught me one time about to pee in the trash can in the kitchen. Yeah. Oh goodness. Yeah. That's tough. All right. Chapter 3. So now and this is the very beginning of statistics. I mean, everything that we're talking about right now is statistics. But this is going to be the beginning of the journey that we're about to go on. Because now we're going to begin to calculate pupils. Right? We're not drawing graphs anymore. Well, we have a few, proportions and relative frequencies. Those are good. But now we're moving into how we're going to be able to represent a distribution, okay, population or a sample. Okay? All right. All right, here are our learning outcomes. So we're just going to cover the first one right now. Understand the purpose of measuring this. And then we'll move into the next slide. No, on Monday. Right? This is it. Yeah. 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 We might have to. Yeah, we might have to move it. Yeah, we might have to move this. Okay. Yeah, well, no, it's going to be. Yes, I'm going to cover. Yeah. So we're going to cover it next week, and then we'll take our. Yeah. Yeah. Because this chapter is not long, but it is a lot of information. So we'll start on today, finish up on Monday, have a little review, and then, yeah, yeah, right. You will need to know about the summation, obviously, because when we do a mean, what is it? How do you get an average? All right, so that summation is, you're gonna see that. All right, and then the frequency distribution, obviously, when you see tables, graphs, you can be able to interpret uh, what's going on. You have to get information out of it. Okay? All right. So central tendency. Central tendency is just a statistical measure. Mean, median, and mode are the three that we'll discuss. Okay? And it gives you a single score that defines the center of a distribution. Okay. I did have an example of you saw the skewness or looking at the number distribution. The center was that the peak, right? That was the peak. That would be in the case of any continuous variable, you know, IQ score, height, weight. That peak is the average. Okay? That is the central most point. It's the center of the distribution. If a distribution is skewed, then the center is no longer the peak. It would be the median. And we use the median for those types of distributions. We're talking about the middle of the distribution. You want to have the reason why we do the single score is because we want a score that is representative of an entire population of samples. Okay? It's the most typical, it's the most representative score, most representative measure of the data that is collected. Okay? And we have one score to identify. The average GPA students who come into Alabama A&M is around 3.1, 3.2. That's the average. Okay? The average GPA for students in college, in every college, is around 2.5 to 7. All right? Those are averages, but I can represent, man, y'all may not have it. I might have it with higher GPA, but on average, the average student has around 2.7. What happens? See the degree. Right? See the degrees. Okay? But again, it's the most typical, the most representative. Okay? Here are three, those are like little things, but here are three different distributions. Okay. All right. So here are three separate distributions. And with these distributions, we use the center would be something very different. For this one, we probably use 5, right? That distribution, right? So for this one, there would be the center. But not really. Even though there's 4 here, that's an extra center distribution. Right? For this one, what would be the 5, right? But it's not representing, right? So we probably have 2 centers because these are 2 separate graphs. It's possible. Yeah, it's 5 more. So we have 2 representatives, right? We have 5 more. Okay. All right. Okay. So the central tendency measures, we're going to talk about them. We're going to go over them very shortly, very briefly, and then we'll follow them Monday. Okay. So figure 3.2. Okay, this is figure 3.2. It shows no single concept of central tendency. Right? No single concept, right? Because if we go back, the center could have been anywhere. Here, and you know the center is probably 5 there. But in these two, A and C, we really don't know, right? And so what other central tendencies that we use, and we'll talk about, okay? When you talk about the center, different shapes require different conceptualizations of the center. So A, we saw that peak was the center, but in the neck was, okay, is this negatively skewed or positively skewed? Negatively skewed. See the chart with the diagram. Yeah, so again, the points that way, going towards the middle, negative. Okay. But here we couldn't really determine, right? And C, we can't really determine that because, yeah, that might be just the modes here because we have 2 different centers, okay? 2 different separate distributions. Okay. But we want to figure out what and choose that one best score that represents it. So we're going to talk about the mean, We're gonna talk about the median. We're also talking about the mode. Okay? This will be easy because you know all three of those things. You've been doing statistics since you were in elementary school. Yeah. All right. So here are some notations. Here's some notation. They ever ask you for the mean, or what we call the average, this is how you would compute. You don't have to write it down, you already know it. But look at the notation. Right? This is the mu. All the mu. This is AM for me. This is for the population. So we got big N. Big N represents the entire population. Okay. Little n represents a sample. This is the summation. Remember that? We're taking the sum of all our x values and dividing it by the total number of schools. And this is the population. Sum of the x value, sample, dividing it by the number of that sample. When you're asked a question on a test or any question, they're going to tell you whether they're referring to the population mean or if they're referring to a sample. Go ahead. This, yeah, so this is just, yeah, it's just sitting. So this is population mu, okay, this is the Greek symbol mu, and then this big N is population. Same. Those are notations that will be used. So if you compare it, the only thing that's changing is the representation of what the average is. Go ahead. Mu. MQ. Just mu. Yeah. They use this versus this, you'd be able to understand this because this notation is universal for statistics. So you would know that this was sample mean if they just used it. Usually, 9 times out of 10, when you're looking at research, it's almost impossible to calculate the population mean because we can't. It's oftentimes impossible to calculate the score for every person in the population. But I can get a sample. It's easier to get a sample. I don't really need to show you this. You know how to calculate the mean. The mean is, again, the center point. It's what you consider the balance point. Okay? You're going to have to sit halfway between the highest score and the lowest score every time. Always going to sit between the highest score. And you're adding up all the scores by the individual. Here's an example of what I mean when I say middle of the balance. So sit at a balance. Two scores here, two here, but see as the balance. Got the max of 10, minimum is 1. Okay? So it's just sitting above the balance. It was at 10, 12, 15. What was it? 10, 12, 22, $2. Blah, 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 blah. Okay. All right. The weighted mean. Okay. So this occurs when you have, say you have two samples. Okay. You have two samples, two sets of scores. Two sets of scores, maybe you have two classes, and you want to do what we call a weighted. Right? The weighted mean is taking into account the number of people in each class, the number of people in each group. The number or the group with the most numbers provides more information. And since it provides more information, the weight has probably been weighted more towards the group with the most information. So I had a group of 10, and they have a mean, and I have a group of 5, the group of 10, and when I weigh it, the weighted mean should probably be floating more towards the mean of the larger group, okay? Because again, that group is providing more information, okay? And it's influencing more of the mean. I'll show you what that means. You combine it in two sets of scores, and then you find the overall mean where they combine. So here is the overall mean. With 1, with 2, divide by the total mean. Okay. Okay. The last thing, and I'll show you an example. Questions about weighted mean? That's it. You can call it E. I mean, that's how you. Okay. So you have two samples. Okay. One has a sample size of 12, another has a sample size of 8. Okay. This is the total number of scores. So you have 7, 6 for the mean, so the sample means. Okay. So if I wanted to combine them, all I'm doing is combine the total number of the sample. I have the 72, 6 together, those scores, and then I divide. 128 divided by 2 is 64. Give me 6.2. Like I was saying, this mean is going to be more closer to 6 than it is to 7 because I think the 7 has more information than provided. So it's 12 versus 8. So it is closer to 6 than it is to 7. All right? Because again, when the samples are not equal, the weighting will always be closer to the largest sample. Okay. All right. Is there anything for you to do? And we are. Sorry.
That's what I'm thinking.
See how much you put for the hoop?
It's
We're looking at the total now. So we have, how do you find an average?
equal.
So the average, right? So we got 80 equals. So I have 2 out of the 3 values, right? So I got my mean, listen to the first one. I got 8 equals, then I got the 10, and then 8 is 4. And then side, yes, 2. 2. The first one. Yes, no.
That's right. I look at
Yeah,
the
yeah. So then second one is, go ahead. Okay, yeah, go ahead. Then once you have that, then you got, yeah, you have the sums, then you divide it by the total number of percent. All right, it's just like this, then you got x1 x2 over n plus 1 n 2 overall. Got an answer. We got a whole class here, man. We're gonna figure it out. Teamwork. Hiccups. I hate it. It's the worst. I'm gonna go ahead and work it out. Okay, so this is 40. Yeah. Well, yeah. I see that. All right. That's all we got for today. It's the way mean and mean. Great job. Great job. Great job today. I think y'all gonna do well. I think y'all gonna do well. Y'all see that, Kimmy and Wanda?
Yeah.
Okay.
Yes,
Y'all
sir.
got any questions?
I don't think so. Not today.
You said what now?
I said I don't have any questions today.
Okay, good. And again, if you have
No, but
anything,
I'm gonna have some on Monday though.
yeah, just come back on Monday and we'll answer whatever you got.
All right.
All right. Have a good day.
All right, y'all have a good one.
All right.